Welcome back to the second part of the session, where we'll talk about machine transliteration, right? And again, I'll do the same thing. I'll go over a brief history of what machine transliteration, how the research has evolved, right? I'll start in 1994. And this is the first paper that I came across. I'm sure there might have been something before that also, but this is reasonably one of the important starting points. We have this paper on algorithms for Arabic name transliteration, right? So you have Arabic has a different script, and if you want to transliterate names in that to English, how do you do that, right? And there was initially a lot of interest in that. Up to 2002, you could see a few more papers on Arabic. There were also some work on Thai and so on, right? And then around 2009 is when Indian languages, or transliteration of Indian languages started taking or started taking some prominence. And around that time also, it's when Google released its first input tools, right, which are transliteration based. That means you write the same example that was given in the morning, you type GHAR and it gets converted to GHAR, right? And that continued for quite a while, right? And in this period, up to 2011, 2012, all the models were again like very similar to the machine translation models, which is they were statistical. They were based on the same IBM paper that I had shown earlier, most of them, right? And there was this detailed survey in 2011, which of course had many sections. It had rule-based systems. It had some statistical models and so on, right? Now, what is of interest to us is again the recent history, right? Like 2018 to 2022. In between, like transliteration, was losing some interest, I would say, in academic circles. But again, in 2018, there was this paper from Google which was on processing South Asian languages written in Latin script, the Dakshina dataset, right? And what this contributed was both training and evaluation data for Indian languages, right? And it had broad coverage of many Indian languages. And then since then, we have made a significant contribution just a month back, right? And our goal, as I said, for all languages, we want to do this IN22. That means go to all the 22 languages. And we're close to doing that for transliteration. We have already covered 20 languages. And we also have state-of-the-art open source models for transliteration now, right? So this is the main thing that I'm going to talk about today. And this is the problem, as I said, right? We want to enable Romanized typing in Indian languages. You write BHARAT, and it should get converted to Bharat in the Devanagari script, right? And our contributions again have been on these three axes which I mentioned for translation, which is data, models, and evaluation. Very similar story. We curated a large number of parallel sentences, not sentences, parallel words between English and Indian languages, mined from both monolingual and parallel corpora. And I'll talk a bit more about how we did that. Then we trained these large-scale joint models with innovations specific to Indian languages. And the key idea here behind training these joint models was to again ensure, so if you know Devanagari, the Devanagari script is shared by many Indian languages, right? So it's used for Hindi, it's used for Marathi, it's used for Konkani. In India, it's also used for Sindhi. Then it's used for Maithili, it's used for Nepali, Bodo, Dogri, and many languages, very diverse languages. All of them use the Devanagari script, right? So now if I have large amounts of training data in Hindi, can it benefit all of these other low resource languages? And that's why it's important to train these multilingual models where the key idea is the idea of transfer, where transfer happens from one language to another. And we had a very interesting discussion in the panel, right, where I think one of the questions was the role of benchmarks. And that's crucial. It was well answered that benchmarks need to be created. And so one of the main contributions that we had here was to create these robust evaluation benchmarks, which are very diverse in nature, right? So which just don't have, when you look at transliteration, right, on one hand you have transliteration of names, but also you have transliteration of common words, right? So I just want to type KI and it should get converted to key in Hindi, right? And this is very different from taking like a complex name. Maybe it's like a slightly longer name and transliterating it, right? So the benchmark should have coverage for all of this. So that's the main contribution that we made, right? Now coming to each of these individual components, so mining data at scale. So I spoke about Samanantar earlier, which had these kind of parallel sentences, right? So India will wear the orange jersey in match against England on June 30. And now the parallel sentence, if you look at it, it contains Team India 30 जून को विश्व कप मैच में इंग्लैंड के खिलाफ नारंगी जर्सी में खेलेगी, right? Now, the words which are underlined in blue or highlighted in blue, these are all transliterations from each other. So they're sitting there in the data, right? We just need to extract them and make these transliteration pairs. And now, if I do that, I can train a transliteration model using this data, right? So the model will learn that wherever I type JERSCY in English, it gets transliterated as J, R, S, E, right, in the Devanagari script, right? If I have large number of such pairs, and such pairs were sitting in the translation data that we had mined, right? So this theme of how we approach language technology, where we create resources, and then those resources start fueling research in other areas, right? So we created IndicCorp, from which Samanantar was mined. Then we created Samanantar, from which the Sakshanantar was mined. Right? So this is a interesting theme for us that we build on the work that has been done in the past. Right? Similarly, for IndicCorp, we just took all the words that are there in our corpus, right? So a list of some million words. And now we used an initial transliteration model, which may be of low accuracy, right? And use it for transliterating the word, and then search in our English word list if this word matches something fuzzily. And if it does, then we mark these two as transliteration pairs, right? And that way, again, we were able to mine a large number of transliteration pairs from IndicCorp 2. The net result was that we had close to 20 plus million pairs mined from these two corpora, and this is like almost like a 10x improvement or even more than that over what existed before this. And the improvements that we got in the model performance based on the data that we collected is something that I'll talk on subsequent slides. Apart from this, we also collected data manually, right? And this is like a very interesting effort panning the entire country, where we had 68 language experts working across India, and we had participated with Desi Crew. You heard them during the panel in the morning, and they helped us collect these 103K word pairs across 19 languages, right? And we had an interesting maker checker setup so that we verified the quality of the data, because as opposed to the mined data, which would have quality riders, this was manually created data, so we wanted the quality to be at a certain level, right? So we had this makers checker step, and different types of Indic words were romanized, right? And we also had this tool Karya from, again, Patri spoke about it in the morning, and we used an automatic validator inside the tool to ensure that it gives signals to the annotators if there are errors in their transliteration, right? Now, with all this data, we trained a transformer-based multilingual model. So again, multilingual is important so that transfer happens across languages. And I gave the example of the same Devanagari script being used for multiple languages. Similarly, the same Perso-Arabic script being used for multiple languages, Kashmiri, Urdu in particular. And our models cover all the 21 Indian languages, right? And this is the last summary slide that I would have on the results. So this was the Dakshina benchmark. So in our history journey, I had said in 2018, this benchmark had come out, which was released by Google. They, of course, had trained their own models and evaluated on that. And we were able to show significant jumps on that. And the two reasons for that, one is if you look at the x-axis, it's the amount of training data. So our training data was much larger because we mined these 20 million plus pairs, as I had explained earlier. And second, we had used a re-ranking algorithm, which again uses words in IndicCorp to re-rank the output of the model. And using that, we were able to get significant improvements across all languages, right? So these data sets which we have created and the models that we have created are publicly released. They are available on Ulka. They are also available on our GitHub pages. So now what we are going to do in the rest of the session is quickly walk you through how to use these models, how to deploy them, how to fine-tune them, and so on, right?